Party, Jen.
Recording in progress. Welcome, everyone. This is a Christmassy time. We're doing microscopy today, right? And I wanted to, for sure, talk to you guys about maintaining your microscope, right? How can we clean it? So are you all in for that right now? I can also just describe it to you. You don't have to do it right away, but one of the things that I want you to notice, if you go from your 10x to your 40x and you see that there is a loss of quality or a loss of sharpness, or there's more of a halo around everything, most likely on your 40x objective at the tip, a little bit of a biofilm has been created. So the way to check that is you just unscrew your 40x out of the nose piece, right? And you look through it, and then you can see crud on the outside. If there's no crud, you can see right through it. If you do see crud, then just pick a cotton swab and spray some. I have a spray of
isopropyl
lens cleaner. And I spray some lens cleaner on the tip of the Q-tip, and then I clean, while I look through it, I clean the end of the tube, right, of the objective, and then the other end is clean or dry, and I dry it then afterwards. It takes me about 4 times of sweeping it, cleaning it before the crud is off. So once it's cooked in there, you need to do a little bit of scrubbing carefully, but with a cotton swab, it can't hurt you. The lens cleaning fluid is also not going to hurt your objectives. But it's usually the 40x objective that has the crud.
Tanja, could I ask a question there?
Yeah.
I used one of those cleaners and I actually scratched the lens of my camera with one of those buds, with those cotton buds, you know. So I'm very skeptical using those again, because it was I had to get a new camera altogether, you know. But
really?
did you ever come across that?
Horrible.
With those, that they're a little bit adhesive. Now maybe it was the poor quality lens that I had, you know.
I have it in my. Oh, where's my cleaning?
Dan, Tanja, while you're searching, Dan, when I went into the pharmacy to get the lens cleaner fluid, he pointed out that there was 2 types. There was one for contact lenses, which is saline.
Yeah,
and
right.
The other one, which is alcohol based. And he said, don't put the saline one on any optics because there could be salt grains in it.
Yeah,
and it might scratch. So he didn't have the. He called it isopropyl, I think. He didn't have it. He said to go to a car parts shop, because the mechanics use it a lot to clean car parts, and the beauty of the alcohol is it dries off, so that's why they use it. It cleans and it dries itself.
Right.
Brilliant.
So
that's
so
handy to know.
Maybe it's the alcohol versus salt thing that.
Yeah, perhaps I bought a cleaning kit from Euromex with everything in it, and the cotton swabs that are in that cleaning kit is the ones that I use, not my ordinary cotton swabs. I haven't used them yet.
Yes.
Okay.
Yeah.
Okay.
I got one of those on eBay as well, I think, or I think it was Amazon, one of those kits for cleaning, you know.
Yeah. Yeah.
Do you know what I did find was pretty handy was I'll just show you this thing. It's basically pumps air.
Yeah.
And it just blew the stuff off it. I don't know, is that any good now? But
yeah, I like that one too. Yeah.
Yeah. Sorry, go on. I'm diverging.
No. I love it. So do you guys think we need to take the time and clean the 40x objectives of yours?
I wouldn't mind, yeah.
Yeah. Okay. So then what I invite you to do is to unscrew, and you have to put in some, muscle in it. Unscrew the 40x objectives from your nose piece. And then here, I'll do it too.
And we're only cleaning the outside part of the lens, not the part that screws in.
So mine comes with I can just unscrew it real easily. There you go. And then I look through it. Yeah, I can see. I should point it at a white. I can see I can clean some of this. So I'm going to also do this now. Whoops. Find my cleaning kit though. Where do I have it? There you go. Wow. Come here, my little pretty. I have to open it because I got a new cleaning kit. Trying to get the stuff out is let's pause the movie. No, just kidding.
Tanya, did you ever notice that when you're sometimes the slide can actually contact the 40 lens, 40x lens? I found that, and sometimes fluid just kind of seeps up into it and it blocks it.
And
it seeps up into it and it blocks it.
Yeah, it does. That's why we need to clean it.
Yes, so that's cool. So it's basically the inside. You don't clean the side that's connected to the nose at all, do you? You never have to clean that.
No, I only clean the outside of the lens on this side, and this one screws in. So brilliant. Here's my lens cleaning fluid. No smear. Yeah, it doesn't say if it's alcohol or not. It just says it's for lens cleaning. Take one of these. And then I'm going to wet it with my, 1 second, do that here. It's going to go. Yep, nice and wet. And now while I look through it, I can see where I need to be.
Oh, I see, yeah.
Yeah, it's a little bit. Yeah, almost.
I've made mine worse. I can't get the cotton bud into it. It's too small. Yeah, I actually have fluid on it now.
And now with the other side, I dry it just to make sure it's dry. When I look through it, it's now completely clear.
Yeah. I'm after making the dogs dinner of this.
Yeah, my one is the same, Margaret. It's very small, and I wouldn't be able to get into it.
Yeah, no, I can still. I like turning the eyepiece as well backwards, and you can really get a view of it.
Yeah, you can see how cruddy it can get, right?
Yeah.
But I want you to feel comfortable and then if you screw it back in, really give it the last push so everything is really screwed in, because otherwise you'll go through your cover glass, right?
Oh yes, I have. Yeah,
screw it in real well.
Yeah, I'm not. I'm gonna have to get a piece of tissue and try and roll it up. I'm not getting into it, and I can see the liquid on it.
I have two 40x objectives. One is for dark field and one is for light microscopy. So I'm screwing off the other one, checking it. Doesn't really look dirty, but I'll clean it a little bit. Which one is the wet side? Don't know. Not wet anymore. Wet it up, clean this baby.
Tanya, how big is the
Perfect.
the opening there in that? Is it very small? It is. Would it be 2 millimeters?
In mine, it's very small as well. Yeah.
Yeah, mine is like I'd say about 2 million.
Yeah.
No?
Yeah.
Well, if you look at the other side, yeah, mine you would be a way smaller than yours now. To be kind of like a 2 millimeter diameter, you know.
I don't know if they're all the same. It's standard, right? The
Is it?
48.
Right.
So I think they are all the same.
Okay, yeah.
And give it a good push so everything's really connected again. You don't want a millimeter out. You want it connected again.
Yes, yeah.
Good. So good to feel comfortable with your own microscope and that you can clean it. And regularly I have to do it. It's because I'm clumsy. I try not to be, but it's good to have your own, what do you call the thing if you have a medicine and then you have a whole list of things that you should and shouldn't do? What's that called again?
Oh, I don't know. Instructions.
Yeah, here, I'll translate it because it's a good word. Oh, like a leaflet or a package insert or an insider.
Mm-hmm.
I'm not familiar with the words.
Just the medicine instructions. Yeah,
the medicine instructions. So I have my own medicine instructions because I'm clumsy and I, once I get excited and I push the 40X into it, right? And then sometimes I go through a drop, or I was doing something with nematodes, but on a Rhodak plate, and then I went too deep and I put my objective lens into the fluid. Of course, I tried to correct it, but every once in a while I need to unscrew them, clean them properly. As long as you know that you're like me, then it's best to master these cleaning things, because if you have to send it away, it's such a hassle.
Oh, it is in Ireland.
Yeah, that I agree with you. It's a nightmare even to try and
Has
find
anybody
somebody.
Found anybody down around here? I had a guy in Dublin and he wasn't able to clean it properly. But getting from West Cork to Dublin, Dan, have you found anybody?
Yeah, Margaret, I went to a university, well, a college in Tralee, and they didn't have anybody. And I went to
none of the schools here.
Yeah, none of the secondary school actually didn't know how to clean it themselves. So we have a big problem. I think there's a really a good enterprise for somebody to start up.
When I have some students here in the Netherlands, and when I go visit them, because I always check out the microscope and do a little cleaning and teach them how to do it. And then it's better to be comfortable with your own microscope.
Yes.
Yeah.
I also have this big cloth that I got from my spectacle person.
Glasses.
Yeah, glasses person. Yeah. I just went to the store and said, I need something big for my microscope, and he just gave it to me, right?
Okay.
Yeah. So, and with that, I clean the aperture where the light comes through, clean it, just move over it. And the same thing, right? What the thing that comes up from the condenser, with this cloth, I also go over that just to make sure there are no hairs, cat hairs.
Yeah.
Revenge for torture.
Yeah. My cat loves the dirty water. If I have the dirty water and the clean water, the cat loves to drink the dirty water. He puts his paw in and then so it gets really messy.
Eating the organism.
So they know what they want to drink, probably.
Yeah, my dog, she loves the dirty water outside. The dirtier, the better. She has no interest in the clean water.
Yeah.
As they do, amazing. They know better. Their intuition is much more astute.
Yesterday, I read a report on cattle. So it's just general cattle, not just cows or bisons, but cattle in general. They can detect a half-point Brix difference in the vegetation that they eat.
Wow.
Because they want to get the most nutrients, whatever they forage, right, for. And it was so interesting to read that. I thought, of course, because that's what I see them do anyway. They just first move their mouth right over the grass before they decide they want to bite into it.
Mm-hmm.
Yeah, they're smart.
Much smarter than we are.
Yeah.
And if there's willow on the edge of a field, that you'll see cows going over to eat it because it has painkiller properties.
Absolutely.
Not only that, it is a natural dewormer, not only for cows, but also for sheep and goats. They will go up to a willow and eat some of it. It's a natural dewormer. And then it's not so harmful for the animals. Ivermectin is, of course, actually very harmful for the animals who are being treated like that. But it's also harmful down the stream, right, of life, because it really messes with the endocrine systems of the microarthropods, right? And so we overlook all of that stuff because we don't see them. Yeah. Okay, good. Now that that's finished, one of the things I wanted to treat you on is my presentation on microscopy as a detective story. Is that okay if I take you through that?
Please.
Yeah. Okay. Where is it? Here it is. Share. And then I have to say present. Do I present now?
Yep, it's showing. Yep.
So for me as a consultant, right? And everything I'm saying right now, it's me as a consultant figuring stuff out. I'm not talking like a mentor from the school, right? Because can you separate that, you guys? It's okay, right? Okay, so it's my experience. It's not school policy. It's my policy, right? That I grew over time. So also be aware, because I had a huge mental dip as well, looking at soils and how badly degraded they are. On average, I do 60 soil samples per year, sometimes more, sometimes less. But looking at so many soils and seeing that they're very badly degraded, it does something to your psyche. So I just want to warn you that we need each other's support. We need to keep each other from going, what do you call that? Depressed. It does depress me when I see these really bad soils. Sometimes I can only find life in the top 5 centimeters, but when I was in Spain, I had to go down 10 centimeters, and then the next from 10 to 20 centimeters is where I found some soil life. So we have to go look where they're hanging out, right? Are they hanging out in the, they need their own living space, right? And if we can't find them in the top 10 centimeters, which is where they should be prolific, right? Prolific. If we can't find them there, it does say something really bad for everything below that, because the top 10 centimeters usually has enough oxygen, right? Just by atmospheric pressure, and they are oxygen-loving creatures, so they should be living there. So if they're not living there, it should give you a clue already.
So Tanya, are you saying that if we don't find life in the top 5 centimeters, that we should go down a bit further and check?
Yeah, sometimes,
I just want to clarify that.
I sometimes take the top 5 and then I go in again and take the 5 to 10 and put it in separate bags.
Yeah.
Just because if I do the 1 to 10, put in the whole apple core, then I have the 5, top 5 and the bottom 5 mixed, and I see nothing at all. Sometimes it is in the 5 to 10 centimeters that I find the live, and sometimes only in the 0 to 5 centimeters. And when I do, it kind of shocks me. And I just want to tell you guys, it might also shock you over time to see how badly degraded the soils are. It's not you not finding, it's that they're not there, right? It's not
like my sample yesterday.
Yeah, yeah. And, you know, the first thing we're going to do is doubt ourselves and think that we've done things wrong. But that's why there are some tips and tricks to check yourself. That's going to be the next slide.
Yeah,
So,
Tanya, could I just say something there very quickly? I've looked at a lot of samples, even in kind of ground that hasn't been worked, and in hedgerows and things, and I've found very little fungi. And you know, I was sort of doubting whether was I doing things right, whatever, or getting the samples properly. But even in it's where there are heavy soils and where there's not a lot of air that I don't know. That was my experience on it, and I just see what everyone else thinks about it. But I've found very little fungi, and that's, as I say, that's not even heavy intensive ground. It's kind of ground that's been sitting for a year, for 10 years, you know.
Yeah, well, they move slowly.
Yeah.
Dan, if you sit back a little bit, then the microphone can pick up your voice better.
Cool, thanks.
Yeah.
How's that, right?
That's better, yeah. Yeah, so yeah, if we see that they're absent, we have oops, something happened. If they're not there, we have to introduce them. If they're not with enough of them, we can help shift them, right, by just adding more of their species. Let me continue, because otherwise this is going to drag on too long. So I do ask growers about their weed species, right? Because I have, you know, weed species will tell us a whole lot. So that's another lecture that we could engage in. But weed species are either going to tell you there's a biological problem or it's a chemical problem. And it's the weed species that have to appear in groups, right? It's not just one type of weed that is going to tell you about your soil. You know, there are then a group of the species of weeds that are going to give you indications. So I'm always interested in the weeds. Ask the grower about it. They're very irritated by weeds, so they know them by name. And that's good, because then I can write them down and figure out what this group of weeds indicate. I also want to know about the disturbances per year. And sometimes it adds up to, every time they go to cut the grass, it will take 6 passes, you know, every time. So those soils are heavily burdened. But I have to tell you, once you have repaired the soil, you can drive over it as many times as you want, and it's not going to compact your soil. So once we repair that topsoil, you can go over it, and you can test this yourself. Once you have cured or brought a soil back to health, you can go right after it, run over the grass. You can put your penetrometer in and you'll see no difference. You can still do everything as before. There's no impact. But there is an impact if the soil is collapsed, right? Okay. I do the nematode scan 3 times. 3 different drops. That's my policy. I do 3 drops, and I take the average of the nematode scan. Now, I do the nematode scan, and I go into the main assessment right away before the drop dries. It doesn't always work like that in the summertime. You know, then my drop dries when I do the nematode scan, and that's why I have to put on a second drop anyway, because of the main assessment. But then I quickly do the nematode scan again, just to count real quickly, and I do it with 10x. I try to identify them at 10x, and I teach as best as I can to my students how to identify them already at 10. Because if you see the T, the carticularized valve of a nematode, you know already it's a bacterial feeder. You can continue to scan, right? It just cuts time. Now, if they have knobs, I do have to dive in to make sure, who is it? Is it a fungal feeder, or does it have knobs, or is it a switcher? Then I do have to go in, and sometimes that takes time. So anything I can determine at 10x, I can move, right? I can be quicker. The other thing I do with the 10x is I look at the organic material. That's on the next slide. 1 second. Let's do it slide by slide.
So Tanja, on the nematode scan, you do the first of your 3 nematode scans, and then you do your main assessment on that same drop.
If it's possible, if it's not dried out, yeah.
Okay. And then after you've done your main assessment, you do 2 more nematode scans on 2 different drops.
Yeah, on 2 different drops, just to make sure. And then as I see stuff at 10x, it confirms what I saw in the initial assessment. Oh, okay. I see a lot protozoa, or I see the lack thereof. I see I want to see the same picture. Every drop will be slightly different, but it won't be a huge standard deviation difference. We shake it, and when I take out a new drop, I do shake it twice, wait the 10 seconds, and then take the second drop, right? I don't take the second drop without, I shake it as if it was shaken for the first time. I don't do the 30 shakes, but just 2 times to mix it up, wait 10 seconds, take on a second drop. And I do the main assessment by the book, right? And the other drops are actually just confirming. It's because I get insecure. Am I doing the right thing? Am I overseeing it properly? That's why I take the average of 3 drops. Gives me my security, right? Like I said, it's not school policy, but mine. I have to support my own insecurities.
Yep.
We all have them.
Don't we all?
We want to judge the sample by its cover because it's going to give us some clues. Also, whatever the question is of the grower, I'm going to keep that question in mind when I assess the biology, right? Sometimes it's why is that patch not working? Well, the rest is. I always love to have pictures or a video clip of my grower. They all have iPhones. They can shoot a movie real quickly and send that to me on WhatsApp. So I have more of a picture of what that soil looks like. Look at the color, right? Those 4 questions are really helpful. If it's already powdery gray, it's a collapsed soil, right? If it's rich and dark and brown, then that's really makes my eyes happy. There are a lot of red soils as well, but if they're dark red, they're fused with humics. So light red would also indicate a powdery collapsed soil. The structure, I look for breadcrumbs. Now, let's think about breadcrumbs. I don't know if you've ever cut open a fresh bread. Those breadcrumbs are nice, thick, and fluffy, right? And as the bread ages and you cut another piece of bread, you get a different crumbliness, right? Maybe it's females that are more aware of this, but I look at the type of crumbly structure. Because what we don't want is to see a lot of clods. Clods is actually compacted soil that is put together. That's not what I'm looking for. I'm looking for a nice bread crumble structure. That informs me about aggregates. They couldn't have been made without the microbes. So if I see crumbliness, I'm happy already. I go, oh yeah, that's been the work of the microbes. Many a times I don't see the crumbliness, right? And I look at a collapsed soil. Moisture level, very important, because if it's too dry, they can't survive. They need a coat of water. So to test it, right, your non-dominant hand, you just have to put some, and I usually do put a latex glove on to prevent contamination. I put some of the sample in my hand. I just fold it. You don't really squeeze. You just fold the hand. You open it. If it stays together, it is 30% moisture, and that's what you want to see. If you open your hand and it falls apart, it's below 30%, and the microbes are going to have a difficult time. If you fold your hand and water drips out, you don't even have to fold your hand. You're looking at mud, right? You already know that's way too much water. Oxygen has been depleted because it's very difficult for oxygen to diffuse into water without it being stirred, right? If water is in motion, oxygen gets in. And then the smells. We want to smell. If we smell nothing or it's very neutral what we smell, then we're not smelling the microbes. And, you know, usually when I do smell soils that are sent to me, I smell sand or I smell clay, right? I don't smell anything like woody or conifer or anything like that. And then I already know I'm going to do my best, but I might not find any microbes. If it's stripped of life, it won't smell of anything. So I connect the conditions of the sample to the biomass ratios. And I look at two ratios, of course, the fungal to bacteria ratio and the predators. Do we have enough protozoas and nematodes? We need the predators for the nutrient cycling. So another one on, let's take a look. So when you do the nematode scan at 10x, you can already get a feel for the microbe representativeness because I can see in the depth the testate amebas, right? I won't see any naked amebas, but I can see Arcellas in the depth. I can already see fungal structures, right, without even doing a deep dive. But when I go do my 10x scan, of course I'm looking for the nematodes, but at the same time, I'm looking at the color of stuff. Yeah, that's also going to be talked about. So then when I do go into my main assessment and I look at my first field of view, I do go through the whole drop because I do want to see what the bacteria look like. I want to see diversity. So many times I only see cocci. It's just occasionally that I see the rods, right? The little dashes. So I am looking for diversity in microbes, but I'm also looking at the density because I want to make a guesstimation. So it's a 1 to 5 or a 1 to 10 dilution. If I look at the microbes, how much more do I have to dilute it in order to count the bacteria? Because it cuts my time of making a dilution, right? If I can guesstimate, probably if I dilute it to 1 to 100, I can count the bacteria. So that's the mental picture you take of the mass of bacteria, and you teach yourself the intuitions, actually. I look at the background color of the sample. You can only actually see that not on the screen, but through your eyepieces, because there is the refraction of the water makes it look differently on your screen than through your eyepieces. So yeah, if it's white or milky, usually is a sandy soil, right? Pink or reddish, you'll have a lot of iron in there that has been oxidized, and the orange indicates calcium carbonates, which is very, very, very hard water, right? Look at the color of the aggregates. 72% dark chocolate means humics, and honey colors mean fulvics. Fulvics are made in the combination of the secondary metabolites between groups of bacteria and groups of protozoa. That's what they do. They make the fulvic acid. Now, the fulvic acid is then taken by the fungi, made more complex, and then it becomes a humic acid. That's only fungi can do that. So if you do see humic acid in your soil sample, which is wonderful to see, then you know either, and even if you don't see any fungi in that sample, you know fungi lived there. They left the humic acid behind, so it is possible to live there. We just need to improve the conditions for them to take up home again. So you can understand that if I don't see stuff, my heart gets heavier and heavier. No life, no humics, only a whitish sandy soil with hardly anything else but bacteria. Oh, it hurts to see. And I use determination rules for everything so that I can be sure that I'm looking at an organism? Do I see a testate? Does it have a double wall? Is the Yersinia a double wall? You know, just have all these determination rules in your head to help you, guesstimate who you're looking at, right? It's especially difficult with small and big flagellates. You know, the more oxygen there is in your sample, the bigger your flagellates are going to be. And so they can sometimes take on the size of small ciliates, but then again, you have to train your eyes on the way they move and make your call and say, oh, it's a flagellate. Yeah. And of course, difficult with soil samples is to distinguish between just ordinary plant material and fungi. That's difficult in soil samples sometimes because, you know, as roots become more woody, you will see structures that look like a fungi, but they're really a root system. So that's why we have the 5 characteristics of a fungi. Clear-cut ends, organic matter does not break clean. So that's why it's so important to look at the tips before you make your call. It's a fungi. Yeah. Again, judge a sample by its cover. Look for signs of succession, right? Nematodes also have a succession in them. What is it? Bacterial feeders are the easiest ones to find, and they are the easiest to adapt. They don't have many requirements to be in existence. But if you're a fungal feeder, you have more requirements. You need fungi to be there, right? If you see a fungal feeder, you have at least a system where fungi must have been found. Same thing with predators and omnivores. They have more requirements. They also hunt protozoas. They don't only hunt nematodes. They're omnivores, right? They need to eat more. So if you find a predator or an omnivore, you find somebody in the nematodes that is higher in succession than the bacterial feeder and a fungal feeder. Same thing with protozoa. Arcellas are higher in succession. If you see arcellas, then they're associated also with fungal biomass. It's good to notice the succession in the microbes, right? And you want to see diversity, different colored fungi. And we're looking for signs regarding to oxygen conditions. So if you see a cilia, and they're not bad, right? They're the good guys. They help clean up stuff. They're wonderful, really. But if we do see them, let's also look to see if we see other signs of lowered oxygen conditions, actinos, rotifers. Just be on the lookout, right? Be clued in. I just received soil and compost sample, and I can already see by just looking, answering my 4 questions, all the organic matter is still recognizable. So I don't think that compost has gone through the heating cycles properly. I already took a look at the stuff. I mean, it's basically bacterial dominated. I don't know how they produce this compost. That's going to be the follow-up question, but it's not compost. It's just oven-dried organic material is what I'm guessing, that they just are asking me to check if that's compost. It's not. And you might run into it as well. You just see recognizable organic stuff, right? So all the time, ask yourself, what conditions am I looking at? Because that's how they operate. They operate in groups, not individual. They operate in whole families together. What conditions are necessary for them to be alive? So if they're not there, then what conditions am I looking at? What does it tell me? And then this last sheet, oh no, this is the last sheet, is the tolerances, right? All of the microbes are just like us. They love comfort. So they want enough water, enough oxygen, enough food, right? And also they have their seasonal stuff. Some of them just have this circadian rhythm. Notice it's November and say, oh, November, time for me to go dormant. They'll go dormant until April or whatever their rhythm is. So, yeah, right now, if we go and take a look in the soil, I'm sure we'll find more stuff that is in cyst form, and then we don't have to ask ourselves the question, why are you in cyst form? It's seasonal. But in summertime, if I see amoebas pushed into dormancy, I do ask myself the question, why did you feel the need to take a break, right? Is it oxygen? Is it water? Is it food that you had to close off and be inactive? So then I do want to ask myself the question, why do I look at cysts? What's happened? Okay. So these are all little details about oxygen. When are you going to see the bacteria you don't want to see? Well, when oxygen levels have dropped below 6 parts per million, right? First ones you'll see are the lactose, because they are very good in that facultative region. But it will tell you that there is something with the oxygen level if lactobacillus are terribly happy, right? Because it's their condition. Okay, same thing with nematodes. If I look at a woody area and I see no nematodes, that's really bad, you know. Then I think of toxicity, because if you have a woody area, you must find at least 10 or 20 in one drop. If I see none, then there is some kind of toxicity that drove them away. It could also be lowered oxygen conditions, because they're beneficials. The only ones who love the lowered oxygen conditions are the root feeders, right? So if I find 20 root feeders, then I know the beneficials were driven out because of oxygen. Yeah. All right. This is probably too much to go into all the details. You can probably print screen this, right? Yeah. Develop your intuitions. So, like I said, in your first field of view, when you look at bacteria, make a guesstimation and then check yourself. What do you count? 15, 30, or 50 bacteria, right? And the more you do this, the easier it gets. I keep track of the color of all the fungi, because that's when I notice diversity. If I have a dominance of one species, that usually isn't good, right? If it's all the same color, the same, I'm still happy I see them, but a lack of diversity is not how nature works. Everything is redundant, like triple, you know, four times redundant setup, so that if some party cannot perform, some other party can perform. So we don't want a dominance of one fungal species. That is actually not a good indicator. And when you do see a lot of minerals and it's a compost sample, you've got to ask yourself, did the leaves, were they coated with sand? Or is somebody cheating the system by just adding soil or clay? Because I do get samples sent of compost where they added clay in the recipe, and then you see a lot of minerals in the sample. I think it's cheating, but you know, okay. If it's a soil sample and all I see is minerals, I'm just looking at an early successional soil, right? There's nothing in there. It's just minerals. Osmotic shock is something you can only see through your eyepieces, not on the screen. And it will look like everything is suspended in zero gravity. It will look like this. It's very strange to look at. So you will notice it immediately. And then hopefully you'll remember me telling you that's osmotic shock. It repels each other, actually. That's what you're looking at. That document.
What's that from? The osmotic shock. What's that from? Is it?
It's a you can have that if there is too much nutrients added suddenly. The high concentration of nutrients actually gives a huge imbalance in the water, and then either it will rush nutrients into the microbes, which makes them pop, or it draws it out and it makes them collapse. It's the same thing. We drink salty water on the North Sea. We would dry out. We wouldn't really give ourselves water. We would dry out.
Okay.
It's osmotic shock for us. I love that table of successional biomass ratios, that document with all the, yeah, I have that. It's also what's behind SMAP, but it's really great to be familiar with that document. And then when you do track soil improvement over time, it's best to give that a visual, make it into a graph so you can see the improvements. You know, if you see populations growing, it means conditions are good. Otherwise, those populations wouldn't be growing. Over time, you want to see, especially also as the season gets more active, they should also grow on their own, reproduce. But, you know, we also, humans, we don't reproduce if we are thinking that it's not a good time to have children, right? Then we are very careful. We don't do the same thing with the microbes. If conditions aren't good, they wouldn't reproduce. That's why I love kissing testates, because I know, hey, conditions are good, or they wouldn't reproduce. I do look at old chemistry reports and analyze the 6 ratios that Graham Said has set out to just get a guess of how well balanced or out of balance the chemical part of the soil is. And then when I have to send them into hostile territory, usually actually I first put in a protozoa infusion to see if they survive application. But if I do have to send in my microbes, I will send them in with food packages. So in hostile territory where hardly any food, they need something. And I know the necromass of their bodies will help build water stable aggregates later. So it's not completely a waste, but it's, you know, I want to have, you know, the microbes that I grew up, you know, that I want to not kill them. I want them to survive when I put them into hostile territories. Okay. And then this is an overview. So and this is for compost. So good compost, bacteria, you really want to see 10 to 15 different species, right? For the fungi per field of view, and that's units on a scale of 10, which is the same scale of 10 that we use, right? We also do that. Just 2 units or more is enough, but with a diameter of 3 or bigger. And then preferably in the same field of view, 1 protozoa or 1.5 protozoas. I don't know how you count 1.5, but never mind. And then nematodes, at least 1 per drop. And then you can, and all the fungi need to have a color. You want to see many aggregates, and then you can say that's good compost. And so if you go down the list, what's really bad is when you see corkscrews and vibrios and all of that, then it's really bad. But it's a nice overview to give yourself an intuition, right? As you do microscopy, to get a feeling for what's good and what's not good. Yeah. Goodie.
Handy table.
Yeah.
And this is then, it's a little simple to say a sample doesn't match the successional stage, right? Shift the soil. It's easier said than done, but that's what we need to do. So you get a sample and it doesn't at all match the successional stage, then you know a lot of work needs to be done to shift that soil. Lowered oxygen conditions, compaction needs to be resolved, because otherwise they won't survive anyway. And I don't want to send them in. I do want to solve the compaction. Once OMI seeds are dominant, it's absolutely important to work on compaction, because even if the hard pen is lower, right, that's still anaerobic conditions. It also prevents the groundwater from coming up because the hard pen prevents it, and you'll always have this deathly graveyard, right? You can't put your roots down deep enough because that's where the gaseous stuff starts to come up from the anaerobes. So yeah, if we have OMI seeds who have gained dominance, we definitely need to work on compaction and get the beneficial fungi to clean them up. But the beneficial fungi need oxygen to live. No nematodes, that's toxicity, right? Nematodes are supposed to be the most prolific creatures in our soils. They're stripped in the soils that I look at. No nematodes whatsoever. But they used to be the most prolific species to find, right? It was natural to have 20 nematodes in one drop. Now we can find one and we count ourselves happy. Yeah, makes me sad. You can already, I can hear it in my own voice. Okay, no protozoa. We gotta look at the irrigation. It's usually because of irrigation water, there's something wrong. And that's when I have no protozoas. I look at the irrigation water.
Is bad irrigation water or?
Yeah, sometimes it's because the water is way too hard and that kills the protozoa. Or there is toxicity in the water and they didn't notice, but when it gets tested, the report comes back and now we know. That's why we don't have protozoa. So the only thing is, if I have no protozoa, I will ask for tests for water. Yeah.
Okay.
Ciliates and actinos, still very good conditions for brassicas. Just ask what they're growing, right? I have enough farmers who grow Brussels sprouts, right? They don't need a high successional situation. It's perfect. So go ahead. And then no life. Oh my God, how many times when I see hardly any life. Well, the only way to beat it is to have cover crops. We need living roots. We need living food for them. And that's the only way I know how we can nurse back that topsoil. Not only microbes, we need the roots. It's always one whole system, right? They need everything. Root feeders, it's compaction that we're looking at. They usually did not show up at all. We didn't know about them until we started to do massive, large-scale agriculture and destroyed our soils. That's when they showed up. We called them into existence. That's it for that detective story. What do you guys think? I mean, it's just me and my brain talking to myself.
Huge amount of information there, Tanja. I need to look at that a few times. There's so much to absorb. It's absolutely brilliant.
Yeah.
Oh, okay.
It's great,
yeah.
great to get it synthesized like that. Like even that slide on the succession, do you know where the good soil is the one with this situation of bacteria, this situation of fungus, protozoa, and so on. It's great to see it synthesized like that because, yeah, there are when you're looking through the lens, I'm sure it'll come with practice, but there are so many pieces you're trying to draw on and to have, I call them cheat sheets like that.
Yeah. Yeah.
That are hanging on the wall and you can go, no, yes, aha. I have a clue now. So
yeah. And it is a lot of information, right? That is all true. But I think still this is the best way to get familiar. And I love microscopy, right? I love to figure out who else is operating in the system. And that's another thing I need to talk to you guys about. If a field that is that I'm not familiar with yet, I want the apple cores not broken up. I want them to send me the apple cores whole.
Yeah.
I will break them up. And sometimes I'll just look, at one apple core and I have my little pin set and stuff like that. I'll go down to the roots, right? And I'll just select the soil around that root system. I know it is selective sampling, but that's exactly what I'm doing because I want to figure out who's running the system. Because I know once I break up everything and it's representative, it's different. So I want to look. So sometimes I look very selectively and then just to double check, I will make it representative and look again. But it's the detective in me just really wanting to know what's running the system. How can I help it nurse back to life? What is it telling me? Yeah. So about sampling, it sometimes pays off to have a pin set and just pick up the root hairs that you can find, right? And be very selective in what you look at because there's some answers to questions that I want to have answered. Who is who is working there. But then when I have to do the main assessment, I will absolutely use the schools. I go by the book then. But before I do that, I will, I'm kind of inviting you guys to become detectives with me.
Yeah,
Now,
that makes a lot of sense. That does, because I've often looked at soils, and you take a sample out, and there's so many different parts to it. As you say, the piece where the root is, or it's so different to another piece. So I think that's a good idea, but I know it won't give you it won't be for the main assessment, but it's a great way of just seeing what's there.
Yeah. Also, if it's an apple core and the top is nice and dry, but the bottom is kind of wettish, I will also look, is that anaerobic? Am I looking at ciliates? If I mix everything up, I don't know where they are residing. And so it's just so that I can understand what's going on, right? Mm-hmm. Yeah. Yeah. So, yeah. I do have long, intensive talks with my growers about sampling, and they have a lot to say and think. They've taken many samples before for chemistry tests, and so it's really good to talk to your growers also about how they look upon sampling.
Yeah, for chemical analysis, it's completely different.
Yeah. But they do have thoughts about sampling and how random to be, or how to be specific. Yeah, let's only look at that one corner or just around this one hedge or whatnot. And so I rely on the intelligence of the farmers themselves, right? When we figure out what's really your question, what's really the question. I spent some time on that as well, because I know what I can answer. So I need him or her to ask a question that I know I can answer. Yeah. So it is 2 minutes to 12. I need to go torture my cat.
Okay.
That will take about 15 to 20 minutes, because I also have to prepare his food, and then I have to kind of stand there and make him eat. And sometimes I have to seduce him with some cat candy because he doesn't like this diet at all.
Okay.
So
no problem. Thanks very much.
Will we come back at 1:15?
Sure, I will close my video and my microscope, my microphone, and then I'll come back. I'll just keep it open.
Yep.
Perfect.
All right.
Okay, we'll go make a cup. I'll go make a cup of tea anyway.
Yeah. Good.
How's your compost, Dan?
Oh, not too bad. It's
Show us those muscles.
Spiked again.
Yeah, I left the chimney out, and my mentor said, "Look, leave the chimney out," and I'm delighted I did, because it just showed me it kicked off again. So no, I'm learning loads. It's just been unbelievable just to see what's going on, and it's great talking to you guys on the WhatsApp group.
Isn't it fantastic? Yeah.
And it's the more we do these, like if everyone does one, it's just so interesting. Even when you don't even comment, you can just watch it. And I'm learning, like, the amount I built up watching all your composts first. Yeah, I've advanced myself, and I tell you, it's good now. It's fun. It's not like work at all for me. You know what I mean?
Frustrating fun.
I know our families probably, and our people live with us probably think we're completely nuts, but it's I was telling by people, I was like, smell this, it smells sweet, and I reckon it was the oats. You know the way you bake kind of flapjacks?
Mm-hmm.
You get that smell of oat, like it was this fresh. I mean, I didn't eat it, but it was so.
But you felt you could.
You could, yeah.
But you think at the temperatures it's got to, like, it's baked.
Yeah, like, guys, and I'll tell you a bit more about it as well on the WhatsApp group, but Mick was telling me he used oats he used hops, which was a beer mash, and he got massive heat, and he had to mix or turn about 8 or 9 times,
Wow.
But it's out there whether it'll work. I also, some of my browns there was a lot of greens in them, maybe because that was clippings I collected over the year, and I cut them in the summer, and they were sitting in a
Okay,
pile.
so you would have had nitrogen in some of them.
Who knows? Now, do you know, I'm going to put all this up at the end, and I'd love to hear people's comments and ideas. But if somebody else does one with the rolled oats without the greens, or we might see then which will work, but it's a process of elimination, really. And the more we test, the
Yeah,
more we look at our
absolutely.
compost together, it's it's amazing now,
I'm
Have
hoping
you
to kick
started
off
yet,
a
Elise?
yeah, I'm hoping to kick off a pile this afternoon. I've been
Brilliant. No, I seen the cage up, and I said, there's someone else now. So that's
Yeah.
brilliant, because it kind of keeps it fresh in your head, and you can just watch it as it's going. But
Yeah.
and then we'll try and document them a little bit. I mean, I've mine on the compost log. I think
Yeah.
I can share that with you guys, as far as I know. If you're
Oh, yeah.
on Google Drive,
Oh yeah.
because
Very good.
I'm doing it with my mentor, and he's watching it as I'm going, So
Yeah. Very good.
but
Yeah, I'm going to do 100 bucket pile, so it's 110 liter buckets, so it's actually a 50 bucket pile, really.
50, right? About
Yeah.
cool.
And I am using rolled barley. And
Brilliant.
I'm going to go for 15%, so 15 buckets of rolled barley.
Yes.
Out of the
Cool.
100. So it's soaking now. I started soaking it this morning at 7 o'clock. It should
Right.
be soaked by 2 o'clock, and I was out cutting weeds off beds this morning for my greens.
There's
And
greens. Excellent.
we'll see. I have the same question about a woody pile that I'm using. It looks like it was a hedge. We've a guy he's a tree surgeon, I suppose, in the area, and he comes by with his van sometimes and just dumps a pile here.
Yeah.
And I think this was a pile of hedge clippings. So some of it is slimy because the leaves have started rotting. But then in
Yes.
other patches, like there's clumps of wood sticking together, wood chips
Oh,
too.
lovely. So you have your
Yeah.
fungi.
Yeah,
You
so I'll be
see-
Some
breaking it up, but
sacrifice.
I'm wondering how much green is actually mixed in there. So I'm glad
Yeah.
there's
How
the
old it is?
15. It's 3 or 4 months at this point, 3 months. Maybe.
Okay. There shouldn't be a lot of nitrogen left in it at this
Yeah.
stage.
Yeah, you'd
Well,
say not.
do you know what, guy? Elsie, that's so interesting, because that's exactly what my browns were. I used wood chip for some of it, and I also used, and that was me. I was cutting hedge clippings and taking them home and throwing them in a pile, thinking they'd be brown. So I bet you're going to get a load of greens in there. It's hard to know, though, isn't it? It's so,
Yeah.
you think it would be rotted down, as Margaret is saying. It's a difficult one to figure out. But do you know
When
the
you
thing
chip
is,
it, though, it breaks down faster because you've opened up more space. And
yes,
when you chip the greens, when it gets broken up, it'll decompose much faster than
cool.
if we say it was the full leaf.
Yeah.
Because they have to kind of break open the outer film, for the want of a better word. I'm sure Tanya would have a much better way of
I
explaining
know you're
this.
right. It's
But
the
once
surface
they're
area.
so they will decompose faster.
Cool. Yeah.
Yeah.
I mean, do you know the other thing, Elsie? And I like it. This is proved to me, and we were very curious about this. The oats, and could we use them? The rolled oats. But it shows that we can do compost in the wintertime, and
Exactly.
there's no problem with heat, because this
Yeah.
is the first compost. And now I've gone the other way.
You could
but,
heat your home, Dan.
I could, do you know,
Have a
I was
composting
honestly,
room and just have pipes going around the house. I'm
yeah,
telling you.
that's it. I was so amazed. It's just been, I mean, I'm blown away by it. But
Yeah.
it just proves that we can. Because I was very skeptical about heat,
Yeah.
and I was also, my God, doing it in the winter, it's going to be cold, and
No greens.
it's
I'm
the
worried
exact
about the
opposite.
greens. So, but we'll see. We'll see now. Like,
Yeah.
will the old buttercups come into their own?
And there's your
Yeah,
calcium
I
as
mean,
well.
do you know what I'm very interested in, guys? Right? Is could we use these chimneys? Right? You put in a pipe in the middle, close it off, Now, if you do have heat, you open it. It's kind of like controlling a stove in your house.
Mhm.
That at least you've a little bit of control. Now, both mentors are, they're kind of not very kind of encouraged to use them. Now, I get it, and I know that's their experience, but I'm just wondering, and I have to answer this question, if we do use them, that we just have a little bit of control, instead of it like, I mean, mine, right? Every second day I was looking at it going, Jesus, I have to turn. I lost, thank God the weather was bad because I lost so much time. I mean, I don't mind it, it kind of worked for me, but like it just shows us we might have a little bit of control with the chimney, but I'm going to do the chimney again today. So when I turned it, so we'll see now tonight, and I'll put it up on the WhatsApp group, and you'll be able to see. But it might be worth it.
Have you ever done Johnson Sue? Because
No,
that
I
uses
went.
chimneys, and
It
you don't
does, you
turn the
see.
Johnson Sue at all.
I
Yeah.
love that part of it.
But the
Brilliant,
problem,
isn't it?
I've heard a couple of the Soil Food Web mentors doing a comparison, and so on the upside you get amazing fungal output from it at the end of a year. On the downside, it takes a long time, and if you don't turn it, then you can't be sure it has all gone through the thermophilic phase, where the bad
Isn't that
guys are
where the
killed.
worms come in though? Because they go through everything.
I suppose.
And that's the time element.
Yeah, you would say so, but I'm not sure. I would have that question too, Mags. But what I've heard is that the worms don't get everywhere, and they don't mix it to the same extent as you taking the top, middle, and bottom and separating them.
Tanya was saying to use Elaine's recipe.
Yeah.
And the Johnson Sue method. I haven't done it yet. I do intend to. But just try it anyway. I love the idea of not turning. I find that my age and my body, I do struggle with it.
Oh, it's backbreaking. Yep.
Yeah, it's hard. It's hard to get the time. That's what I see with it. And just you'd use an hour. I don't care what anyone says. You'd be an hour at it, no matter what size it is.
Jesus,
to do it right.
I wish I was only an hour. I'm 4 or 5 hours building a pile, and I'm 3 to 4 hours turning it.
Yeah.
And building it, like I spent all of yesterday measuring out the, setting up the cage, setting up the pallet, measuring out the oats so that I could have them in 2 sealed cans so that the rats wouldn't be eating them overnight, and wetting them this morning, gathering wood chips, gathering old, just gathering the stuff.
Yeah, it's massive.
It's 2 days.
It's the materials, you're right. It's so hard to get the material and get the timing of them all kind of ready at the same time.
Yeah,
but
it'll be great fun to see how it goes.
Yeah, it will. I mean, I went to that Sue Johnson day, and I watched them and I seen it all, and I was very interested. My point, and I'm kind of curious, and it's what you said, Mags, about the worms. Did they get to everything? But the temperature is not going to go up, so I don't think you're going to kill off any of the anaerobic.
I think that's why Tanya was saying to use Elaine's recipe rather than what Johnson Sue would kind of did on the course. That way, then you get temperature, but it doesn't. What was it she said to me? It should cool down between 5 and 10 days.
Yeah.
But I know what you're saying, and I have those kind of questions too. But what if? But I suppose it's a different principle, and we're relying more on the worms to take care of what we might have missed.
And maybe after
and we have a microscope.
Yeah.
Yeah.
I asked David Johnson, actually, I said, would you class it more as thermophilic compost or vermicompost? And he said vermicompost.
Yeah.
No way. That's interesting now.
Yeah. So that's the worms, like.
Yeah.
Yes. So then basically,
and they are bloody brilliant.
They are, yeah. Oh, we abused a pile and put it and in a Johnson Sue cage. We didn't know what we were doing. We'd seen this fantastic video about magic compost that showed up. Put in 5 chimney pipes in a cage, so we threw it all in. We didn't know what recipe it was, And we walked away because then we got caught up in a course on horticulture. And then we opened it about a year later, and it is like amazing stuff in it.
No way.
Like stellate amoeba, do you know the ones that look like...
Oh,
Oh,
wow.
the stars.
Yeah,
Yeah.
exactly. Stellate amoeba, testate amoeba, loads of different fungus. So the fungal output is amazing.
Yeah.
And I haven't seen any of the bad guys in any of the
Brilliant.
samples.
No
But-
way.
But I
You
guess
see,
it's not anaerobic. So
Yeah, you know the thing I'm kind of a little bit that I don't like about it. You have to wash everything, don't you? They kind of wash all the kind of fines through it so it doesn't get anaerobic. You know, I mean, the way we did it in that course, there was the amount of leachate. It was like
oh yeah, I know what you mean.
Mm.
I
I
found
don't know
that
I don't know if that's washing as much as trying to soak the stuff. to
Soaking,
make it
yeah.
50% wet. But yeah, there was leachate. I agree with you.
yeah, and I found you were kind of losing a lot of your nitrogen, I'd say, and a lot of your beneficial.
You're
Exactly,
washing,
they're
yeah,
all-
washing
yeah, yeah.
stuff
Which-
out, yeah.
And again, that was a massive amount of work. But no, do you know, the only other idea that is in my head, if we could make something like a pizza oven, right? Basically something that you could put your compost into, have temperature and moisture gauges in it, and have the whole thing coming to 65 degrees for 72 hours, and then take it out. That you're kind of cooking everything at once. Now I know this would be a very technical weapon to
But
to
I know
make,
what you're saying, yeah.
but
And you'd only have to be 48 hours at 65.
correct. Actually, yeah, you're right.
Only
Actually,
2
yeah.
days.
So do you know? I mean,
Sounds brilliant.
it does. Like you'd have to put loads of pipes through it that you could run
Mm.
moisture and run air. So if it got too cold, you'd have to get hot air into it. If it was too hot, you could blow cool air, and you'd also have to have the moisture kind of right. But if you would, I think to me, you could make it a lot quicker. And I know it would be a bit of a structure to make. Could you use a big tarpaulin? But to me, I just find this turning. It's
I
as we've
know.
all said it. It's just so labor intensive. And at the end of the day, you've weeks and you have this product. How long is that going to last you? I mean, if I use it in my landscaping and for greenhouses and stuff, it's not going to be cost effective for me to sell this by the bag. Do you know what I mean? I mean, imagine asking someone for 300 quid for a bag of compost.
Mhm.
Well, the land gardeners are the only ones that I've found where they have that they're selling compost now, biological. They don't say anything about exactly what's in it. They don't give any microbial reports, but they charge 20 quid, I think, for a kilo and a half.
No way.
Yeah. And
Right.
they have people that subscribe to them, so that they get a couple of different deliveries over the space of a
Right.
month or 2 months. They've a huge business built out of it.
Hmm.
Now they're
That's
doing
a-
thermophilic, but how good it is, I
Yeah.
don't know.
Well, tell you, there's one way to find out with the microscope. So
Yeah,
anyway,
but they don't
Tanya's back.
send to Ireland. I would have got a piece from them, but they don't send. They only send it out in the UK.
All right, cool. That's interesting
So
to know.
it'll have
Thanks
to be
for that.
somebody in the UK to buy a piece. That's the only. I think there are other people doing it in the UK, but I'd be less confident on what it's like. They don't seem to. I don't know. It doesn't ring through. Whereas these guys, and they're at it a long time.
Yes.
They would be known for their soil work. So yeah, look them up.
Thanks. Will do. Thanks, man.
What are they called again, Max?
The land gardeners.
Okay.
Nicole Masters did
No.
a course with them this year. So that can kind of
Right.
give you an idea of their caliber.
Okay.
Okay, cool.
I'd be happy to drive around Ireland with a couple of kilos of my own compost in the boot, and then I'd do a fresh batch of extract and sell them that for 20 quid.
That's a
Yeah.
great idea. And that's how you stretch it out as well. But
Exactly.
I've often thought about that. How in the name of God can you sell it? Because Jesus, to go anaerobic in a flash, that's the way to do it.
Yeah,
Be
you'd have to drive
mobile,
around.
good one,
Exactly.
Elise. Yeah, and make it there. God, I'm gonna have to leave the dog out. She's pestering me.
Okay.
Microbes for sale.
Yeah, exactly. Snake oil saleswoman.
Yeah.
Except
Yeah.
it'll be microbe oil saleswoman. Yeah.
So I thought maybe this second part of the hour we could actually go hunt, right? And do a little bit of detective work. So if one of you is willing to pop up a drop, I would love to hear the answers to the 4 questions: color, structure, moisture, and smell.
I had a
Okay.
slide ready this morning, but it dried out.
Dried
so
out, yes.
I'm
yes.
going to, but I have another slide here and my thing should still be okay. Has somebody else got a?
I
I'll
can
have
do
to
one.
just put one together.
Okay.
Okay. Whoever is going to take the lead, you do have to inform us about the 4 questions so we can detective with you, be detectives.
Okay. Well, I don't know which one of us will be ready first. Mine is, I did the, my lovely, oh, I could be too much organic matter, I'd say there.
Well, let's do this. All 3 of you are going to put a drop on. Megs,
Okay.
you're the first one to answer the questions. Elise, you're the second one to answer the
Okay.
questions. And then Dan, you are going to also answer the questions. So we have 3 different types of samples. Let's start detecting.
Do I have to share screen?
Oh, 1 second. You have to, of course, share the screen, but we still want to know, is it a soil sample, a compost sample?
I went for my wood chips, my Ramiel willow wood chip.
Okay, we're looking at
because
wood
I
chip.
thought it would be a bit different.
Nice. Okay, now still talk to us about structure, color, smell, the whole works.
Okay. The smell is, it's kind of woody.
Yeah.
I suppose. And I don't know if you're never going to be able to see that, I'd say, really. It was chipped on the 8th of August. So it is, so today, 4 months old. It was Ramiel willow. And I'm specific about that because that's the smaller pieces of the wood. You're kind of around 3 centimeters in diameter and less. So it's much more active. The lignin isn't as, I don't know what I say, condensed. So it's easier for microbes to break it down. It also has more nutritional value, which is why I do Ramiel. What is the other color is, it's still structurally, it's still quite woody because it's only 4 months old. So even though on the sample I can see bits of aggregate starting. So that's color, smell. I can't remember the 4. You're going to have to remind me.
Moisture, if you put some in your hand, does
moisture,
it fall apart?
okay. Now being just wood chip, it's fairly wet, it's outside, so I don't know how to quantify that.
Well, if you put some in your hand and you just fold your hand, does it fall apart?
Kind of, but I can feel moisture on my hand, a little bit of moisture on my hand. There isn't moisture running.
No, so moisture level is most likely fine, but it doesn't have any structure holding it together. Let's say
there's some of the pieces are held together because they're bound by fungi. There's a lot of fungi in it.
That's what I wanted to know, right? So you already see some aggregate making in the work. Yeah, good.
Okay, and what's the 4th?
The 4th was smell. No, structure. The crumble structure.
Well, okay, it's wood chip and it's only 4 months old. So, but there is some structure happening because of the fungi.
Yeah. We see them dishing. Very good.
Yeah, I know, but the soil would be slightly different. Not that compost.
Now, Elise, would you be so kind as to tell us what your sample is and the 4 answers to the question?
Sure. So it's output from the badly abused Johnson-Su reactor. It's funny though, on the surface, so this is a few shovelfuls that we've put in a bucket for me to run out the door and grab samples from, so that I can be practicing. But on the surface of this heap, you can still see pine needles and bits of organic matter. When you go down a few centimeters, it looks much more like soil.
Yeah.
And so it's more decomposed underneath.
Yeah.
So there's a lot of organic matter in it. And so it falls apart if I folded it over, taking right from the top to 5 centimeters down, it would probably just about stick together.
Yeah.
But
that's good.
So there's a changing profile down through the sample. But the stuff at the bottom probably would be crumb structure.
Yeah, very good. The smell, what does it smell like?
Yeah, kind of woody, musty, I suppose foresty.
Yeah, good.
What I would.
We should expect to see some microbes then.
Yeah.
Yeah. And the color, did you tell us about the color?
No, not yet. Dark brown.
Ah, good. And moisture level, what's your guess?
In the lower part, underneath maybe from about 2 centimeters down to 5, I would say it is at about 50%. But the top, the top 2 centimeters are quite dry, like that would fall apart.
Yeah. Well, it's nice to have a little crust because that keeps the rest nice and protected. Yeah, good.
The brambles are coming for it as fast as they can grow.
Thank you, Elise.
Yeah.
And tell us what soil sample you have or compost sample you have and the 4 questions.
Right. This sample is from a raised bed at home. Originally, it was a Hugel Kultur. So basically, that's an awful lot of rotten wood, and you kind of pile it up in a pile. So it is very. I suppose there is a lot of wood and fungi in it, you know.
Good.
Smell-wise, it's a very kind of sweet. Sweet is the way I describe it.
Oh.
A woody kind of a forest floor kind of a smell.
Right.
Is the way I describe
Sometimes
it.
when it smells sweet to me, and so we're going to pay attention, I kind of smell lactobacillus. So we're going to check it when we look at your sample, what the sweetness really represents.
Okay, cool. That's very interesting to know now. Now, color-wise, it is a very dark, I suppose I could nearly call it that 70% chocolate color, because there's no kind of lightness in it at all, you know. So now it's not jet black either, so I'd call it that. Structure, now the structure, there is an awful lot of aggregates in it. It wouldn't be flaky like a flour. It's more like crumbs. So I described, like you were talking about the breadcrumbs, I suppose it is. It has those little chunks. So that would maybe say there's a lot of bacteria in it, beneficial bacteria with glues, and they're gluing it together.
Yeah, we'll have to look. It's interesting. Yeah.
Yes, yeah. Structure-wise, I squeeze it in my hand, and the thing I know about it, when you leave your hand go, the shape of your hand is still in the soil sample. So it means it does keep its structure. Now, my hand was very wet afterwards. So I'd say it'd be maybe more than maybe 40%.
Yeah, that would be 40-50%. Yeah, if your hand is wet, then it's usually 50% still. Yes, I don't want you to squeeze it, though. I don't want you to squeeze it.
Yes, just kind of right. Okay, maybe because that's So I just go a little bit lighter. So and just hold it together, you know. So
Well,
yeah,
I
that's
think
moisture.
we're in for a treat. We have 3
Well,
fantastic different samples. Yeah.
Yeah.
So could you share your screen now, Mags, and then we'll have a look around and see if we can confirm any of our ideas. We should see fungi. And if we didn't, then maybe you should shake harder, right? Because fungi also grab and hold stuff together. They're very
I hope there
strong, right?
is. There was earlier on, but I only gave it a quick shake. Okay, that's a 40x now. Will I?
It's not gone through it yet completely, and I get an immediate message. I have to stop my video for a bad internet, you guys. It would help me, actually, if you wouldn't mind. Ooh, is it okay if I ask you guys to also shut your video while we share the screen? Because for some reason,
Yeah.
I get messages that I'm unstable. Don't feel unstable.
While I'm sharing screen, if I turn off my video, will you still be able to see what I'm looking at?
Yeah, because that's a different video.
Okay.
I can also shut the video for you if you want me to.
Oh, do, Tanya, because
Okay.
it could take me 5 minutes to find where I'm supposed
I'm
to
doing
be
the same
looking.
for you, Dan. I'm stopping your video.
Perfect.
Yeah. And now I'm no longer unstable, it seems.
Great.
Will I do a quick scan of this?
Well, this is 400x. I want you to go to the top of your drop and let us look real quickly at the layers of bacteria. And I'd love for us to see that we have different morphologies. I see coccy's. Can you hold it for a second before you fine tune more? I only see coccy's. Do you guys see rods? Do you see anything else but cocci?
Top right.
You know how to find your view options annotate, right? Can you go higher in the drop so we can look at just the bacteria for now? This is some actino here, action. Cocci, cocci, cocci.
Yeah.
I see small and big cocci. That's at least 2 difference. I don't see rods so quickly.
No rods.
No. And I
That's
did in the other willow pile. Now I know it's willow, it's not. It's just one ingredient.
Right. Well, I'm satisfied with the bacteria. Sometimes you see wonderful motile bacteria as well that shoot away. Now let's center in on that area where I noticed actino, because right now it's invisible, but when you fine focus a little bit, you can see that strain.
Yeah.
And then a reproductive structure. And I think I see some kind of a fungal spore hidden here in this aggregate, but it's just a little unclear.
There, yeah, you can kind of see it there now.
Yeah.
The fungal spore. I can't get in on the actino. I don't know why.
Yeah, it's always very see-through-y, right? But it's a straight line going into this aggregate. And it's okay. Actinos are very good at breaking down stuff. Actinos shouldn't have a bad reputation. They do great work.
Yeah, sure. So it's there. Oh, nearly.
Well, let's go look around, because what we wanted to find were fungi. So you can either decide to do the 10x, so we have a bigger view.
The 10x, so we're seeing more.
Yeah, let's do the 10x. Go up. Or is that go down? I don't know. Now, of course, this is not a soil or a compost sample. We don't see much organic material in this particular field of view. A little bit.
considering it's just wood chip, it's not bad.
Right, let's go look a little bit more because this is just one little place. Let's go look around, not too quickly, just slowly. All right. Because we do want to look at the colors. I see, for my eyes, it's honey colored. It's not really, this is honey colored to me.
Yeah.
And this is darker brown to me.
That it's starting.
Yeah. I want to see more of these. This is what I want to see. And that's why I want to look. So you can also go to 4x. If we keep the colors correctly, we could see even more if you go back to 4x. Okay.
Turn the light down just a little bit.
All right.
Right, need to focus now again.
Yeah.
See it?
Yeah.
I'll move it into the full.
Yeah, we still see the difference in color between honey color and dark brown, right?
Yeah.
Yeah.
But I do think that if if you look at the scattering of the browns, it's likely to be just about 10% organic material. You can look at scattergrams and they give you pictures of what is 10%, 40%, 60% coverage, right? You can familiarize your eyes for that.
Okay.
If you want to look it up. Yeah.
Right.
Just to give yourself an impression of,
yeah.
So broken
is
down
that
enough.
10% humic and 10% fulvic, or is it
No,
both together?
the fulvic is even less because it looks like dark brown has the vote.
So does that mean because there's so much fungi in it, because this is the pile that has massive amounts of the saprophytes, that they've condensed the fulvic already?
Yeah, they're good at work. They're doing the work. We want to see them operate properly.
Do you remember, Elise, when you were here in September with me, and the fungi was starting on it? It's like it's just a mass now. There must be across the whole lot of it, almost 2 feet deep.
Wow.
And it's just a mass of fungi.
Okay, let's go dive in and find a fungal hyphae and just see how well developed and how healthy it is.
I would nearly want to go, for me to go up to the 10x. My eyesight, I find it hard with the
Yeah, of course. Yeah, we need to go to the 10x and then you find something that you want to dive into and then we go into 40x. You're doing it perfectly.
There's a bit of a lag. Now I'm struggling now to get this into focus. Okay.
We're getting there.
Too bad. I think that might have been an nematode that I'm going to move in a little bit because I have an awful lot of organic matter here, and I'll go up a bit and see. Now, this is crazy. I was looking at loads of pieces of fungi on my first sample.
Yeah, they're good at grabbing and holding on to the material that they're working with. Oh, there we go. We see a nice structure.
Will I go down to the one on the left?
Yeah, that looks like a good candidate.
Okay, I'll get you over more to the center and I'll go up to, oops, I went too far. Right, so try you that. Yes, of course.
Ah, look at that baby.
No.
It's uniform in diameter.
Ah, I was trying to get both pieces on the screen because it was branching. Oh shit, and now I've lost it.
It's more to the right. Left, I mean, my other right.
Oh yeah, this is the joy now of dyslexics, Tanya. I'm going to look in on the microscope first and see, can I find it? Oh my God, I have no idea where I put it. Here. Okay, I'd say that's a piece of actino coming down through it. Whereas I thought when I saw it, it was joined. I think that's just something on top of it. Oh. I notice this sometimes, Tanya, when you start to go through, it looks clear, and then as you're coming into focus, you'll see a bit of color.
Yeah, I usually do check it with my eyepieces just to make sure that the refraction of the water didn't give it a different color.
Okay, yeah, because I don't really see color
on that top one
in my eyepiece.
Yeah. It is also not as sharp in your 40x as your 10x, so I am suspicious of some crud on the bottom still. It looks halo-y to me.
Yeah, I felt I didn't get it cleaned properly. I need to go at it again and actually turn around my eyepiece to have a really good look.
Yeah,
I feel there is still stuff on my 40x objective.
But do you guys understand what I'm saying? When you went from your 10x to your 40x, you see this halo effect. That's what I look for.
Yeah, it's like a sheen.
Yeah.
Kind of, yeah.
Sheen is a good word. I have to remember that word.
That you're saying halo, and to me, it's a bit of a sheen. It's like there's a layer interfering with the clarity.
Yeah, okay. True that. So if it's okay, Mags, then I'd like to give the room to Elise.
Oh, absolutely.
Yeah.
Yeah, I had lovely incatriads in it as well, and arthropods when I was looking earlier on. So I'm happy with, considering it's just wood chip. I have protozoa. There was a half a dozen nematodes. Now they were all bacterial. But considering it's just wood chip, I've lovely diversity.
Yeah,
so
good.
Far.
Yeah, good to be used in your compost. It's biologically active.
Yeah, that's why I do. And if I'm using it on potatoes, salicylic acid will help with the phytophthora.
All right.
Okay. So, do I need to stop share? I do, don't I?
You need to stop sharing, and then Elise can start sharing.
Okay.
And it's from the Johnson Sioux compost reactor.
Yeah.
Yeah, looking forward to seeing this, Elise.
So this is the 4x?
4x, yep.
Yeah, let's go through the drop and look at layers of bacteria first.
Look at all the dirt on it. All these things, I think, are dirt. Anyway.
Yeah, I won't be able to say so unless you move your field of view and then spots stay.
Oh, yeah. So this is 4x, yeah.
So we don't see a lot of organic material yet. If you move up to another field of view, do we see more organic material?
Oh, wait.
A little bit.
So this is a 1 to 7.
1 to 7. So maybe go more to the middle, because I think maybe most of it is more in the middle. All right. So you look at the scattergram, right? It's just 10% organic material that I'm looking at, if I had to make a guess.
Okay.
Let's go dive into 10x and see. Oh no, first to the bacteria. Can we look at the layers and see if we have any We have. Oh, sorry, we can't do that until we are at 40x. I'm so sorry. We have to go in at 10x and then look at the color of the aggregates. Nice clear. Good
It is,
camera.
isn't it?
Yeah.
It's not usually this
Isn't
good.
it?
Cheapers.
What do you guys think of the color?
It's more honey, isn't it?
Yeah, it's not really dark brown, huh?
Yeah.
Yeah. Can you move it a little bit more to see if we have different pieces that have color? There is some dark brown in there. Yeah, but it's
Is it half and half? Would it be half fulvic and half humic?
could be. Yeah.
Right.
Yeah.
There's a protozoa there.
Yeah.
Yeah. Hello, testate.
Yeah, look at him.
But we don't
Huge.
see a lot of organic material. That's interesting for Johnson Su. It's, of course, it should be highly fungal dominant, right?
Yeah.
That's an empty test over there. Correct?
Yeah, it looks
Yeah.
like it to me.
So let's go dive in at, yeah, let's take that fungi and let's dive in at 40x and look at it.
That one.
Sometimes in Johnson Su, I find that the fungi are very narrow because of competition. But this one looks like a normal sized diameter.
Septates.
Nice color.
Nice
Light,
color. Yeah.
Light tan.
It doesn't look folded or hurt at this time, so it's healthy,
Mm-hmm.
which is what I want you guys to look for as well. I mean, sometimes you do see that some fungal nematode has possibly punched it, but they can repair themselves, right? Which could have happened here.
Is that a little bit of damage there? Oh, yeah, sorry, yeah. That's exactly it, yeah.
Yeah.
A little bit of damage.
Yeah, but it hasn't folded completely. And when
I
it
get you.
folds, usually it means it's dying.
Oh.
And when it's
Yes.
completely folding. And so I know a lot of students still count that as biomass. I just go ahead. I just know that it's not going to survive.
Not gonna, yeah.
But this one looks healthy.
Yep.
Clear cut. Let's go look for more stuff.
Is that a testate there?
Oh, can you find focus on that a little bit? Doesn't look like it.
No.
Oh, yeah, his
Doesn't
edges
have a
are too
double
jagged.
wall. Yeah.
No,
But it does look that there are little dots on top of it. So I think, you know, some bacteria are finding something very yummy there and they color and decorate that organic material.
Okay. Okay. Sorry, fungal or bacterial count.
If
It's
you
quite
go back up and then hold it there for a while. And then go slowly. That's
cockeye.
cock size, yeah.
Okay.
They're kind of higher up in your drop, the cock size, aren't they?
yeah.
But not a huge mass of bacteria. So I
No.
don't know what your dilution is now.
1 to 7.
1 to 7. So I think maybe even if you just diluted it to 1 to 20, you might be able to do your bacterial count. You don't need to dilute much. I mean, we could almost do a bacterial count now, couldn't we?
Yeah.
It's not that busy. Okay, let's go.
Is that actino there?
No, it looks like organic material that is still in a kind of a filamentous. And I don't see complete cock size or rods lined up in a filamentous organism, right?
Yeah.
Very bumpy, isn't it?
Yeah.
Yeah, it's organic material still held in some filamentous structure.
Yeah, that throws me as well sometimes, but
Yeah.
Look.
Actino is also very uniform in diameter, and this does not look uniform.
what about this piece down here?
Where are you pointing
Sorry,
at?
here.
Ah, yeah, it looks like organic material as well, not uniform in diameter.
No.
Yeah.
Yeah.
But again, no, sometimes there is pieces like that, they just throw you off, don't they? They're
Yeah.
kind of maybe.
Yeah, I understand it. You just have to grow your confidence.
Yeah. Now, I wonder, is that a rod there as we're here?
No, a rod is way smaller.
Oh, sorry.
It is a bit thick, isn't it?
Yeah.
Yeah.
And it's
Yeah.
too small to be a dead lacto. Lactos are longer. So some see-through, whitish, or organic material. It's also not
Right.
moving on its own.
Yes, yeah. It's not entirely straight, is it? It's kind of, yeah.
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 Okay.
Good questions. Shall we go hunt?
Yeah.
Sure. Just scroll somewhere or move somewhere. Lots of
You've lots of spores.
Yeah, those spores are
Yeah.
recognizable. These two are recognizable as arbuscular mycorrhizal spores. Probably this one too. We'd have to look up. But the brown ones usually are the mycorrhizal ones that look like either a coffee bean or like
Lemon.
yeah. But then brown.
Oh, that's somebody here.
Ah, yeah, you found a little flagellate, and it's a small flagellate. Right, I see usually bigger flagellates. You'll notice it too when you do your protozoa infusion and you have a lot of air in your water. Your flagellates will be nice and big. And this one is a small, normal-sized flagellate, so I would say normal, ordinary, normal oxygen levels.
This one here, yeah.
Hello.
Yep.
Yeah,
Munch.
love to see them. Yeah, nope, not finished. I want to know. I'm gonna go around another.
Yeah.
There must be some more. Yeah, I'm going to go around one more time.
Yeah.
You can't travel in a straight line.
Yeah. He can't. Yeah, he's drunk. I listened to a lecture of someone. I just completely forgot who it was. I have to go back over what I looked at. But you know, when they get to have all of their food, the suspicion is that they're completely high, right? They're high on the food and they're just so happy as can be all the time.
You can
That's
see
a nice thought.
Yeah.
you can see his flagellum there. It's in front.
Yeah.
Yeah.
He's
Oh, yeah, you can. Very
making
good. That
little
is some
rounds.
wicked camera.
It is a really good camera.
Yeah.
Elise.
Oh, I don't know. Gee, oh,
Very
okay.
How
good.
many
Yeah, I love the
megapixels
camera
is that?
too.
If you don't mind me asking, how many megapixels is it?
It's 8.
There you go. That, do you know something? I want that on my Christmas list. 8 megapixels.
Yeah, I'd love a new decent camera too.
Yeah.
Okay.
It's a joy if you have it, and it's so much easier to send clips to your clients, and
Yeah.
they fall
Isn't
in
it?
love with it. Yeah.
Yeah, it's like putting on a pair of glasses, isn't it? And being able to see clearly.
Yeah.
Absolutely.
Yeah.
Yeah, when I bought my microscope, I didn't know what I was buying and I didn't know what I was looking at or looking for in the camera, and I just took what they recommended.
Yeah.
Yeah.
Now, there's a tiny guy scooting around. Is that a bacterium? Well, he's so small, I would have said bacteria first. See him?
No.
Well, little bacteria that shoot around are the motile bacteria, and they overshoot their target because they can only shoot in a straight line.
Okay. I don't see any more protozoa in this drop anyway.
No, me neither. Let's go look for more fungi also.
Should I give the floor to Dan? I'm just conscious it's 10 to.
Oh, yeah. Let's give the floor to Dan. Yeah, absolutely.
Okay.
The fungal count is a little disappointing.
Yeah.
Yeah. Now let me recall again the sample of Dan. I don't recall now. It was a soil sample, right? It was from your
Yeah,
raised bed.
sorry. Yeah, a
that's it.
raised bed. It was so
Yeah.
basically basically a lot of rotten wood in it over a couple of years.
Yeah, very
So-
good.
I won't
And-
say that probe won't be a lot of minerals in it, I'd say. Now, can you guys see that?
Not yet. You're not sharing your screen yet.
Sorry, I thought I did.
And also when you share your screen, there is a little box in the lower left corner saying optimize for video.
Yeah, sorry now, I'm just a bit slow to react now. Right, here we go. Share screen. Right. That should be coming on now. There we go.
Yep.
Right.
Have it.
Now, let me just focus that a little bit.
And we have a bit of a condenser issue here.
Right. Now, let me see. Let me just go up. Will I go up to 10x?
Ah, good. The purplish is almost gone.
Yeah. Yeah. Do you know the condenser, when I go down to 4x, the condenser has to be adjusted again. It's not very good now.
Okay, let's do what we did before. Let's look at the organic material. It is more like 40% organic material already, right?
Okay.
40, maybe 50%. It looks nice and dark brown to me, but you'd have to confer it with your eyepieces because I'm not sure the color is reflected correctly.
The color's bad on that. Yeah, you know, looking at
We can't hear you when you talk past the microphone.
Yeah, looking in my microscope, it's mostly humic acid by the looks of it, apart
Dark
from
brown.
a little bit of honey colored, which would be up here.
Ah.
Sorry, I'll just get there's a bit of honey colored here, but the rest of it is humic acid by the looks of it.
That's good. We want to see both, right? We want to see both. We want to see fulvics and humics because that means it's in production, right?
Right. Cool. Yeah.
Yeah.
So, do you know, just looking at that doesn't look like a lot of fungi, but as you say,
let's go cruise around a little
Yeah,
bit.
the humics, they were there if they're not there now.
Right, let's have a look. So, yeah, I'll just have a quick look. Let's see, there is. What about that now?
That looks like a really lovely air bubble.
Yeah, it is, isn't it? Yeah, I just now I wonder if I put 40x on, can we see that? Now I think that's actually not fungi, is it? It's a piece of organic matter or a root.
And how do we know? If you look at the organic, the carbon layers of the walls of an organic structure, it won't have the same layers of carbon because it's not obligated, but a fungi is obligated to lay the same layers of carbon. And that's why this is organic material.
Right.
Now, Dan, if you adjusted your condenser to go more upwards, would it then change your color? It's so strange to have the purple background. That's the fine focus that you're doing now.
Sorry, it is, isn't it?
Yeah.
Sorry. Yeah, there you go.
Yeah, it does.
Yeah.
Okay, you're going down. You have to go up. Yeah.
Yeah, that's up to the max. Now, my camera, you see, is pretty poor quality. So basically, I've got to adjust my condenser basically differently for my camera and my eyepiece.
Right.
So that's the best I can get it now.
Yeah. Okay. We can still see color.
Yeah.
Let's go hunt for a fungi.
Okay, I'll have a look for fungi.
You can go up to 10x, Dan. It might just be easier to find a fungi.
Yeah.
I think maybe the camera software is also adjusting or correcting for stuff.
Yeah, it kind of self-adjusts this one. It's kind of one of the lower quality ones. Whereas I think the more higher tech ones you can adjust yourself better, you know?
Yeah. You're difficult to hear if you're past the microphone.
Yeah, no, I think what I'm finding with this camera is it's very low megapixels, and it has a lot of these automatic adjusters on it, whereas the higher tech one has a lot more adjusters that you can adjust manually.
Yeah.
I'll just fungi there, Dan, over to the right.
Yeah, let's have a look at that. So okay, let's just focus in and see what we can see.
Yeah, you got a fungi.
Yeah, that's a fungi. Thank God for that. Is that a flagellate just running?
Yeah, that is a flagellate. Yeah.
Yeah. This fungi, I suppose it does have a lot of clamp connectors, does it? It just looks very
Yeah, or they're oxalate crystals. It's a little difficult to see, but it looks like it has little bumps on the side.
Yes, yes.
Those would be oxalate crystals.
Yeah. Septa, not so uniform, but the dark kind of color good, all right. Sorry, the pop-ups. Yeah, there's a little damage here. Maybe that's two pieces here, is it?
Yeah, it looks like something's on top of it. Yeah, you are correct. Yeah.
But
there's also a little flagellate here playing around. It looks like it's finding something yummy.
In the organic matter, yeah.
Yeah.
No, do you know, I do a count on this for fungi, and the basically the standard deviation would be way above 70, you know, so you couldn't count it.
Well,
I do find that with a lot of samples I do take in a lot of places that I haven't come across a fungal count that has a standard deviation.
You need to pay attention to when you do your 30 shakes, to really shake hard enough, support your elbow when you do your shakes, because the fungi hold on. Of course, they're the ones that make structure, so they'll hold on as hard as they can. So you have to shake really well.
Brilliant. Yeah, no, do you know something? That's something I'm going to work on, all right, because I wanted to know, was I doing something not so standard that I wasn't getting high readings, you know, kind of of fungi, you know.
You can look at your testate amoebas. If they crack, then you know you are shaking too hard, and you've got to dial back a little bit on the hardness of your shaking, and that's how I fine-tune how hard I shake.
Okay, cool. That's another interesting point. Yeah.
Yeah.
You know the flagellate that went zooming past here a while ago?
Yeah, here.
Yeah. Why isn't that a large bacteria, motile bacteria?
I saw just now, I saw there was a motile bacteria. I have a little clip to show you a motile bacteria in action. Okay. So I can show you that clip.
And because I'm always trying to find or see the flagella,
Yeah.
Before I'll define it as a flagellate, because I see things zooming across my screen all the time, and I'm going, is that a flagellate or a motile bacteria, or is it a ciliate? So when you can't see the flagella or the cilia, you're reliant on speed, size.
But don't the bacteria travel more in a straight line, where a flagellate kind of bumbles and the ciliates just zoom? There's a different movement, isn't there, Tanya, to each of them?
Sorry, I was looking up the things here.
Yeah, Mags, that's what I'm like. What's zooming? Because like I've seen flagellates.
Some of them
like
can go pretty
high
fast, and
speed.
some of the
Yeah.
ciliates can
Okay.
be slower. I know
When I
what you're
start
saying.
this, it's only 10 seconds.
Okay.
And it's you'll see one quick motile bacteria. It's 2 micrometers long.
Okay.
And it can just shoot away. This one is also a motile bacteria. There's another motile bacteria.
Okay, I'm not seeing
That's
those
it.
ones.
Just 10 seconds. It's 12 seconds. I'll play it again. Shoot.
And this is 400x, is it?
Yeah.
Or
This is 400x. Yeah.
okay.
And so these are motile bacteria, and she wasn't sure.
Okay, I'd say it's my eyesight, so I'm not seeing anything.
Oh, really?
Yeah.
Oh, okay.
I need new glasses.
And I have another one, but that is from a student who sent me a predator who was eating a little nematode. 1 second. Do I have it here already? History. Okay, bookmark then. Yeah. Whoops. It is gruesome. So this is a huge predator with teeth, 4 teeth, and he caught a bacterial feeder. Whoops, he's trying to find him.
He's going to break out.
Yeah, we all do this, right? We try to follow them, but they're so quick. Where are they?
Is that's bigger than 400x, is it, Tanya?
No, this is 400x.
Is it? He's
Yeah,
huge,
but the
isn't he?
predator is huge, and it's going to swallow this poor bacterial feeder.
Oh wow.
Yeah.
Jesus,
So
that's like a horror film, isn't it?
it's a horror movie.
Oh yeah, look at that. Wow. He's
And
got
it's
most of them
tail
in.
first. It caught the tail first. That's why it was such a fight. And now he's trying to swallow it.
Wow.
And that little bacterial nematode is still
Alive.
feeding itself. It's still eating bacteria. You'll see that in a moment too when it gets sharper.
Priorities.
It's like yeah. Is it not noticing it's being eaten here? Look, it's still eating bacteria.
Oh my God. That
Maybe
is
it's
gruesome.
hanging on to the bacteria, trying to not to get sucked in.
But it's a hard work to swallow. Do you see it? It's not easy.
Yeah.
Yeah.
Some mouth.
Like
It's
a boa
huge
constrictor,
predator.
isn't it?
Yeah.
Yeah.
It's still grazing. It's still eating bacteria. Silly one.
I'm gonna have nightmares about this.
Yeah.
But look at how relaxed the nematode really is that is being eaten. You know, he's still eating himself.
Yeah.
Yum,
Yeah.
yum, yum,
Yeah.
yum, yum. You're being eaten.
Yeah.
Why aren't you not in a panic? It's not in a panic.
Jesus.
Maybe he gets injected with some
Painkiller. Yeah.
Yeah.
Still eating. It's still trying to eat little bacteria.
Yeah, look at that. That's
Silly one.
That's amazing footage.
It is,
Isn't it?
isn't it?
Yeah.
That is absolutely.
Wow.
He's
Well,
stopping
it's
now.
a hard thing to swallow, you guys, as you can see.
Yeah,
It's
he's
hard
kind of
work.
squashed, didn't he?
Yeah. It's a good thing he doesn't have to breathe. Otherwise, I would feel, constriction in my own throat looking at this.
Yeah. Absolutely.
They're just in such a different world, aren't they?
Yeah.
Yeah, that's it. That's the end of my and that the last clip is that he swallowed it whole.
Oof.
It's in. Well, he's going to lay down and take a rest, I'm sure.
Yeah, exactly.
He gets an Oscar for that, I know.
And it's a bacterial feeder. It's eating. You can still see the T.
Yeah.
Oh,
No way,
Burp.
that's amazing.
it's a hard pill to swallow, I guess.
Yeah. Wow.
Yep. And it's in. Boink. It's in.
Jeepers. Oh yeah, look at
Jeez.
that. He keeps swallowing too.
Yeah,
So he's really
yeah.
pushing it down. Oh yeah, you can
How
see.
wide is that?
Wow.
Wow! My God.
You really get to see the mouth there.
Yeah.
You can't
How
see the
wide
top
was
part.
he, do you
Sorry.
reckon?
Just put it on dev parts, man.
I didn't want to do that. How do I zoom? Oh no, I have to stop sharing. How do I do that now? Did I lose you guys?
No,
we can
still here.
hear you.
Good.
Yeah, there we go.
Okay.
That's it, actually, for today.
Yep.
Yeah,
10
thanks
past
very
12.
much.
Tanya, that was incredible. Thank you
Fun.
so much. I hope your cat is okay.
Yeah. Yeah.
Lads, I just got to see a couple of clips in between while you were talking. I just saw the nematode there at the end. That's fantastic.
Mad.
Savage, wasn't it? Yeah.
Coronation Street, how are you?
I just want to say thanks very much for letting us record it and for us to look back at it afterwards.
Good.
Yeah.
Good.
Yeah, can't
And-
wait to see it.